So here in this question, we're shown figure 1, and it's a sketch of the curve C, which has the equation y is equal to 4x squared plus x divided by 2 multiplied by the square root of x. Then we subtract negative 4 ln of x, and this is valid for x greater than 0. So we can see our parabola-like shape here, and we notice we have a point here which looks as if it is a turning point of this function. So in part A of this question, we're asked to show that dy by dx, so the derivative of y with respect to x, is going to be equal to 12x squared plus x minus 16 root x, all divided by 4x multiplied by root x. So how are we going to do this? So we're being asked to find dy by dx, so we need to differentiate this, and we can see that effectively we have two parts of this equation. We have this part here, and then we have this part here. So we can kind of split these up and do these separately and then bring them back together at the end. So we're first going to take a look at our log differentiation here. So we know that if we are differentiating ln of x, its derivative is going to be 1 over x multiplied by, well, in this case, we have this constant in front. So we'll just write that down. So our first step is going to be the derivative, so d by dx of 4 over ln x. So we want to find the derivative of this. What's it going to be equal to? Well, it's going to be equal to 4, and then we multiply that by our standard derivative of ln of x, which is 1 over x. So then that will leave us with 4 over x. And what I'm going to do is I'm going to draw a box around this and highlight it, as this is a very important piece of information which we want to come back to later when we get to our final answer. So now we want to differentiate this part. So we have a fraction, and we know that when we want to differentiate something to do with a fraction, we're going to use the quotient rule. So the quotient rule says that if we have, say, a function h of x, which is equal to something over something else, so let the numerator be f of x and let the denominator be g of x, and then we can find the derivative of h of x by using this formula here. So we have the derivative of f of x multiplied by g of x, and then we subtract f of x and multiply it by the derivative of g of x, and then we divide everything by g of x, so that's our denominator, squared. So how are we going to do this? So we've got our function here, so we can say, so we're going to say let h of x be equal to 4x squared plus x, and then we divide that by 2 multiplied by the square root of x. So therefore, we can now select functions f of x and g of x. So we'll have that f of x is going to be equal to our numerator, which is 4x squared plus x, and then we have that g of x is going to be our denominator, which is 2 lots of root x. So now we want to differentiate these, so we can therefore say differentiating f of x. What's this going to be? So we'll have 4x squared. We know we want to multiply by the power and then take one away from the power. So we'll have 4 multiplied by 2, which is 8. And then we'll have x to the power of 2 minus 1, which is 1. And then we have x on its own here, so that'll differentiate to 1. So we'll have that is 8x plus 1. So now let's take a look at g of x. What's its derivative going to be? So we know that 2 multiplied by root x is equal to 2x to the power of a half. So we know we can now differentiate this because we want to multiply by the power, which gives a constant of 1 at the front, and then we're going to take 1 away from the power, so it's going to be x to the power of negative a half. What's that equal to? Well, that is equal to taking our exponential down. That's going to be equal to 1 over the square root of x. So then we can use the quotient rule, and we can say that the derivative of h of x is going to be as follows. So we just take our new terms we have here and substitute them in this fashion here. So we start off with f dash x, so we'll have 8x plus 1, and then we multiply that by 2 root x, and then we're going to subtract f of x, which is 4x squared plus x, and we're going to multiply that by 1 over root x, and then we don't forget that we need to divide by g of x squared, which is 2 multiplied by root x squared. So now all that's left for us to do is to take our term here and our term here, and we kind of merge them together to give us dy by dx. But firstly, to make things slightly easier later, we're going to just simplify this h of x derivative here. So this is going to be slightly tedious, but we're just going to work through it slowly. So multiplying out that first bracket, we have 8x multiplied by 2 root x. So that's going to be equal to 16. And then we have x to the power of 3 over 2. So our next term, it's going to be 2 root x multiplied by 1. So we're just going to write root x in terms of that's kind of in this. So we'll have that's going to be 2x to the power of a half. And it'll become clear why we don't write root x and why we're writing 3 over 2 and 1 over 2, etc. As we'll see that things start to kind of cancel out in a second. And then we're going to subtract. So we'll have 4x squared multiplied by 1 over root x. So 4x squared, and then multiply by 1 over the square root of x. So then we have x to the power of a half. And then our final term is going to be x over x to the power of a half. And then we can simplify our denominator slightly here. So it's going to be 4x. So that's what we get when we square 2 root x. So for us next, what we can do is we can just tidy these two terms up here. So we'll have that this remains as 16x to the power of 3 over 2 plus 2x to the power of a half. And then simplifying 4x squared over x to the power of a half. So we can then take our x components together and do 2 take away a half, which is going to be 3 over 2. So we'll have negative 4x to the power of 3 over 2. Doing similar for the final one, we'll have 1 minus a half since we are dividing, and that is going to be x to the power of a half. And then once again, our denominator remains the same at 4x. So now we notice we have x to the power of 3 over 2 and x to the power of 3 over 2, and x to the power of a half and x to the power of a half. So what we can do is we can start to simplify things. So therefore, just rewriting this, we'll have h of x. So combining our 3 over 2 terms, we have 16 minus 4. So that's going to leave us with 12x to the power of 3 over 2. And then we have 2 lots of x to the power of a half. Take away 1 lot of x to the power of a half. So that is going to leave us with positive x to the power of a half. And we don't forget to divide by 4x. So then our next step is to divide each individual numerator term by 4x, and then this is going to leave us with, so 12 divided by 4, that's going to be 3, then we're going to have x to the power of 3 over 2 divided by x, so that's going to be 3 over 2 minus 1, which is going to be a half, and then similarly for the second part, it is going to leave us with 1 over 4 x to the power of a half. And now we can swap back in our kind of square root signs, as this is always going to be neater. Then we multiply that by square root of x, and we add on 1 over 4 root x. So we now have the derivative of h of x, and then we need to remember back to our previous part where we had 4 over x, and now we can combine these to find what dy by dx is. So what I'll do, just for consistency, is I will circle this box here and highlight it again in yellow. So we know that these are the two parts that we need to bring together to find dy by dx. So therefore, we can conclude that dy by dx is going to be equal to, so we're going to have 3 root x plus 1 over 4 root x. And then looking back at the question, we had that we were subtracting 4 ln of x. So this means we're now, for the derivative, going to be subtracting 4 over x. So just writing that in here, we then subtract 4 over x. And then remember what we were aiming for on the question. So we had this fraction here. So we nearly have that, and we can get to that by multiplying kind of these terms here to get our a single fraction. So how are we going to do this? So we can use the kiss and smile technique and multiply the first two terms together. So we'll have 3 root x multiplied by 4 root x. That is going to give us 12x. And then the other part, that's over 1. So we'll have 1 times 1, so plus 1. And then what's its denominator going to be? It is going to be 1 multiplied by 4 root x, and we still have our negative 4 over x there. And then once again, we can just use the kiss and smell technique again. So we have x multiplied by 12x plus 1. So that's going to be 12x squared plus x. And then our other side, we're going to have negative 4 multiplied by 4 root x. So that's going to be negative 16 root x. And then our denominator, what's it going to be? So it's going to be then the two denominators multiplied together, which is going to be 4 lots of x multiplied by root x. So therefore, we'll just kind of look back at the question and see if that's what we're aiming for. So we were asked to show that dy by dx was equal to 12x squared plus x minus 16 root x divided by 4x root x. And that is what we have here. So we'll just write in here. So we've got our answer there, and then we'll go, that's equal to dy by dx as required. So this question was worth 4 marks. So we pick up our first mark for knowing how to differentiate the ln term. So that's when we got to 4 over x at this stage here. We then received our second mark for having a method to differentiate 4x squared plus x over 2 root x. So the method we used was the quotient rule. So we'll give ourselves the second mark when we kind of knew what to do, knew the formula, and started working through this. We then received our third mark for starting to make progress with the quotient rule and substituting the values into the formula. So we'll give ourselves our third mark at this point here, and then we receive our fourth and final mark for getting to the correct answer and concluding that dy by dx was 12x squared plus x minus 16 root x divided by 4x multiplied by root x. And that's us completed this part of the question. So in part B of this question, we're told some further information which relates to the graph. We're told that the point P, which I already mentioned, is the minimum turning point on C. And we're asked to show that the x-coordinate of P is a solution of x is equal to 4 over 3 minus root x over 12 all to the power of 2 over 3. So when we're asked a question about minimum turning points, we instantly think dy by dx is going to be equal to 0. And that's because we know that we can find the stationary points by setting dy by dx equal to 0. And we know that a minimum turning point is a type of stationary point. So the first step here is going to be to set dy by dx equal to 0. So I'll just note that down. Our first step is to set dy by dx equal to 0. So we recall from part A of this question that the answer we were required to show was this. And this is good that this was a show that question, part A, because in your calculations, if you didn't get the right answer or you didn't manage to complete the question, but you do know how to do part B, it's good that you can just take the derivative which you're given to then proceed with this part of the question. So therefore, we take this derivative and we set it equal to 0. And what we now need to do is to rearrange this into this form here. So our first step is going to be to multiply everything by this denominator, because we know if we multiply both sides by this, it's going to get rid of it because it's equal to 0. So this is going to leave us with 12x squared plus x, and we're going to subtract 16 root x, and this is all still equal to 0. So now the strategy for us is going to be to, like I said, get this into this sort of form here. But we can't factorize because we have this kind of not normal term. We'd normally to factorize need 12x squared plus x minus 16. But we have this square root of x here. So we can get rid of this as a first step by dividing everything by the square root of x. So this is going to leave us with 12x over the square root of x, which is going to be equal to 12x to the power of 2 minus a half, which is 3 over 2. Then we're going to add on, what's that going to be? That's going to be 1 minus a half, which is a half, so still root x, and then take away 16. And that still remains equal to 0. So then now what we want to do, we know that this is a term that we're looking for, and it is to the power of 2 over 3. So we know that on this side, that before we took the 2/3 root, this was going to be x to the power of 3 over 2. So this means we want to solve for this term here. So we're going to start to rearrange. So we're going to have 12x to the power of 3 over 2, and that's isolating that term on that side. Then we add 16 to both sides and subtract the square root of x. So therefore, now what we want to do, we can take one step further to isolate this x term by dividing both sides by 12. So I'll just note that down here, divide both sides by 12. So that's going to leave us with, well, we'll have 16 over 12. Then we're going to subtract the square root of x divided by 12 also. So then the next step here is going to be just to simplify this right-hand side. So we'll keep the x to the power of 3 over 2. We know that 16 over 12 can be simplified to 4 over 3. And then our root x over 12 remains the same. So now all that's left for us to do finally is to now take the 2/3 root of both sides, and that is going to leave us with x on its own, and then we have 4 over 3 minus the square root of x over 12, and we pop our brackets in and take it to the power of 2 over 3, and then looking back at the question, this is what we were asked to show. So we've shown that x is equal to 4 over 3, take away root x over 12 to the power of 2 over 3. So we'll just write in here as required, and therefore we've completed it. This question was worth 3 marks, and we pick up our first mark for knowing to set the derivative equal to 0 and getting to the stage where we had then divided both sides by the square root of x. So that was at this stage here where we had 12x to the power of 3 over 2 plus root x minus 16. We then receive our second mark for beginning to rearrange and knowing to do this. So we'll give ourselves this mark when we had 12x to the power of 3 over 2 on its own there. So that was showing we knew the process that we had to carry out. And then finally, we'll then get our third mark when we got to the required answer, 4 over 3 minus root x over 12, all to the power of 2 over 3. And that's us completed part B of this question. So now in part C of this question, we're asked to use the iteration formula, which is given here. So we're told that the n plus 1th term of x is equal to 4 over 3, take away the square root of the nth term of x, divided by 12, all to the power of 2 over 3. And we're told that the initial value, so x1, is equal to 2. And we're asked two separate questions here. So we're first asked to find the value of x2 to 5 decimal places. And then we're also asked to find the x-coordinate of p to 5 decimal places. So to find x2, what we can do is we can use the value of x1 that we're given and substitute it into this formula here. So I'll just draw an arrow here just to highlight what we're going to do. So we're going to sub this in. So therefore, we can say that x2 is going to be equal to 4 over 3. Then we're going to subtract the square root of x1 over 12, and then we take all of that and put it to the power of 2 over 3, and then this time we sub in because we know the value of x1, so we're going to have 4 over 3 take away root 2 over 12 to the power of 2 over 3. So what we do is we take our calculator and plug this in, and this is going to give us 1.138935 and so on. And recalling the question, we're asked to round to 5 decimal places. So we have 1, 2, 3, 4, 5. And we have that the 6 decimal places are 5, so we're going to round up. And that's going to leave us with 1.1389. And then we round up our 3 to a 4. And then we'll just put in here to 5 decimal places. So that's us complete part 1. And then for part 2, we're asked to find the x-coordinate of p to 5 decimal places. So what we can do is we can take this iteration formula on our calculator, which we've just plugged in, and then we're going to, rather than then manually typing this number in, we can replace x of n. So in our case, we just used 2. We're going to replace that with answer. So you'll have a button on your calculator, ANS, and you're going to click ANS when the cursor is in the xn position. So then what you can do is just keep pressing equals, and it'll keep updating it with this new answer, and then it'll get to the point where it converges, and that number which it converges at will be the x coordinate of P. So therefore, you do this in your calculator, and this comes out as 1.15650. And that's us completed this question. There was 3 marks on offer, and we pick up our first mark for knowing to substitute our values into the equation here, and we then receive our second mark for working out what x2 was. So we'll give ourselves our second mark here, that was to 5 decimal places, and we then receive our third mark in part C for stating that this point was equal to, so we had that x was equal to 1.15650. And there we have completed this question.